A very good evening, sir. Am I audible, sir?
You are audible. Yes, yes.
Thank you so much, sir. Thank you so much.
You are audible.
A warm welcome and very good evening to all dear participants. A resource person of today's session, our respected Dr. Atul Juneja, sir, and chairperson of today's session, our respected Dr. Hitesh Khurana, sir. Today, we are having our lecture 2 on descriptive statics, measures of central tendency. Now, I would firstly like to introduce our respected chairperson of the session, Dr. Hitesh Khurana, sir. Sir is currently working as a professor at Institute of Mental Health, UHS, Rohtak. And areas of interest are adult psychiatry, geriatric psychiatry, biostatics, and application of technology to mental health. Besides psychiatrist, Sir is also a musician with good command on flute and violin. Sir has published more than 50 papers in national and international journals. Sir is associated with various journals in the capacity of member of editorial board and reviewer. Now, I would like to invite sir to say some words and give us permission to start today's session. Please, sir. Sir, you are mute, sir.
Thank you very much, Mr. Amit. It is indeed a very honor that you have given me this opportunity to chair a session when speaker is no one else but Dr. Atul Juneja. And I have his CV, and his CV is very interesting. It's particularly of interest to those persons who are from the Ayurveda. Dr. Atul Juneja had joined ICMR in 1983, and he superannuated in 2021 as Scientist F. And during his career, he had been the coordinator of the Clinical Trials Registry of India, and he had also been and currently he is serving as the guest faculty at multiple colleges, which include AU Tibia College Government of NCT Delhi, and he is teaching research methodology over there. And he is also a visiting consultant for biostatistics at PSRI Institute at New Delhi, and he is also associated with the Nehru Homeopathic College at New Delhi. And now the next thing which is going to be, this is going to impress those who are from Ayurveda. He is the member of the National Advisory Board of the Journal of Case Reports published by All India Institute of Ayurveda. And he is also a member of Scientific Advisory Committee for Clinical Research in the Central Council of Research in Ayurvedic Sciences. He is nominated member of the Internal Security Committee for the Central Council of Research in Ayurvedic Sciences. And besides that, he is also a member of DNB committee at Jaipur Golden Hospital at PSRI, Mamta Channar Devi Hospital, New Delhi. And many other hospitals also he is associated with for the course of DNB. Besides that, he had also served as expert in the various advisory boards, which include Central Pollution Control Board and also the Board of Indian Standards. And he had also been a member of DNB committee at BL Kapoor Memorial Hospital, which is a very prestigious hospital. Everybody knows this hospital, and besides that, he had been associated with various training courses all over India, and he has published about 60 papers, in which the 25 papers are as first author, and most of those are in the index journals. I welcome you, sir, and it would be very it would be a very nice academic feast for the audience to from your lectures. Now I hand over to you, sir.
Thank you so much for your very humble words of introduction. I'm really moved with your kind words. And really, as I have already mentioned yesterday, it has always been an honor to be associated with such type of programs, because the organization which has taken up this lead to reach out to the, I should say that, and I can proudly say that, and allow me to say that you are trying to reach out to the last person of the country, to reach out in field of research methodology through physical mode as well as online mode. So that is the best thing what one can think of, because since we all know that the research, knowing about the research is, I mean, many people, most of us know it, and youngsters also are very much interested in new discipline because it was at one time, I should say it's a relatively new in field of when particularly students are associated. So, but we know some certain things, but it is important to know it in an organized way. So these programs have been charted in such a wonderful way with small segments. I should say they are very small segments. As I mentioned yesterday also, that descriptive statistics, like today they have given me only central tendency. I understand that the dispersion would be taken by somebody else. So these are the small things which, so that the knowledge remains sustainable with the student or the young researchers. So thank you so much, organizers. Thank you, Chair, for your very kind and humble words. Let me start by the topic which is assigned to me is the measures of central tendency, which again, most of you know it, but just to have a link for presenting in your protocol writing or a research paper, I mean, you have to, I mean, remember certain things or remind yourself of certain things while you document your research. So as I mentioned that I always believe in linking the things. So I'll use certain basic concepts also in this to arrive at the basic objective of this presentation. Let's remind ourselves that the use of statistics allows biomedical researchers to draw reasonable and accurate inferences from collected information. A clinical researcher or a lab researcher, how good he might be there, but to express the contents in form of magnitude, it's important to make use of statistics. So it should not be considered as a burden, rather as it should be considered as support, and that is the very purpose of these type of programs. And let me just put it that way. The use of statistics allows biomedical researchers to draw reasonable and accurate inferences from the collected information with a degree of uncertainty and to make reasonable decisions. So some people might react, why uncertainty? So now if you're, I mean, I'll not go deep into it, but we always minimize the uncertainty because there is nothing like one. We don't know that this is certain. We have to maximize the probability of uncertainty. So like p less than 0.05 means the difference what we're trying to observe is wrong by 5%. So you keep on minimizing. That is why we say p less than 0.05 or p less than 0.01. So this is the basic principle why we say that degree of uncertainty. So maybe the details would be taken up in the other programs, but just to as a reference, I made a point here. Dr. Amit, I lost the connect actually.
Sir, it's not slide mode. Close the presentation.
दूसरे मोड में आ गया है ये.
Sir, click on stop sharing. Then again open the PPT. Sir, you need to increase the at the bottom right there is a plus and minus icon. Please click on plus. More sir. Yes.
ठीक आ गया. अच्छा ठीक.
Perfect sir, perfect.
So let's remind ourselves what a clinician and clinical researchers looks for. Understand the disease occurrence, distribution, and outcome. This is one of the major purposes. Understand the phenomena of causation of disease. identify the link of causality that are amenable to intervention through general or specific intervention programs, relate the output and impact of intervention, assess the effectiveness and efficacy of the treatment. This is all the whole gamut on which the medical research works on. So I thought before moving on to exactly, we must tell ourselves what actually we are doing it and why we need the summary measures. So these are the things which need to be summarized ultimately. So we should know what we are going to summarize. That is why I have included this particular slide, and I usually include this slide in almost my every presentation. So what are the health outcomes? Now see this. The first one is, or rather the most worst one which the clinician wants to avoid is the death. So death, disease, disability, discomfort, and dissatisfaction. Honorable Chair can feel better about this. The discomfort and dissatisfaction usually form the part of mental health. So if you think your outcome health measures cannot go beyond this, so you have to measure the variables within these. There could be further specific details to the disease or disability, but in broad sense, death, disease, disability, discomfort, and dissatisfaction, which are mainly parameters of mental health, the whole system of outcome health remains within this only. And that we try to summarize. So one is descriptive, and how the statistics is presented. One is descriptive, one is inferential. So today the topic which I'm being asked to do is talks about the descriptive. That means descriptive means you describe things. To put it in a very simple English word, you are describing something. One is inferential. Inferential means now you are inferring about that parameter. So if you think in English, simple English, you are describing something. You are describing a personality. So let's not go into statistics. You are describing a personality. Okay. Then you start inferring, which the mental health people do very well. In fact, inferential means now you have described a personality. Now you start inferring that with these type of people, these things can go wrong, or these things can go good. So these are the inferences what you make. So similarly in statistics also, you study the magnitude, only describe that this is describe the magnitude. But in inferential statistics, you try to describe that magnitude as less or more in terms of probability. That, of course, will be taken up by in the other presentations. So what is to be described? That is basically is a variable. You start with a variable. I mean, you know that something you are measuring, how you're measuring. You have to measure through a variable. Variable is a characteristic, attribute, or a measurement that can have values. It's a quantity whose value changes across population. Across population means it might vary from group to group. For example, consider a sample of patients suffering from diabetes mellitus. The variables for this sample could be age, gender, sugar levels, height, weight, BMI, HbA1c. It could be anything. So you're measuring all those things, and after measuring, you describe them and then infer them, right? So what is data? Data is a collection of measurement of observation. Its value, that is variable, actually assumes. Data can be divided into two different types. One is qualitative data and quantitative data, right? So qualitative data, you all know, is like good, bad, something. Quantitative data means you're measuring height. So you say this boy is tall. So that is qualitative. But when you say his height is 180 centimeters, 190 centimeters, then it is a quantitative data. So if you, so qualitative and quantitative are linked parameters actually. So type of variables are also divided into nominal and ordinal variables. So nominal variables means where there is no magnitude to a variable, but the number defines the nature of variable. For example, you're coding your data, male, female. So usually what happens, you code male as 1 and female as 2. But that does not mean that male has the magnitude of male is less than the female. It has no meaning, in fact. But this is done for the easy data process management issues. Right now we were not talking about data process management, but what happens in this case, when you compile your data, when you write male, female, there's nothing wrong in writing male and female. But suppose if you write small m and somebody else writes capital M, the computer might read it differently, but one would always be one. So just to standardize the data reading capacity of the system, we try to categorize those variables. So male 1, female 2, or dwelling units, rural, urban, 1, 2, something like that, whatever you can feed. That means the number indicates the name and not the magnitude. So in that categorical variable, we have also ordinal variables. Like if you have a disease, mild disease, moderate disease, so you could code mild as 1, moderate as 2, and severe as 3. You can go other, you can do other way also. It's absolutely your choice. There's no hardcore rule on that. It is your convenience, or the rather not convenience, rather I should say that the convention what is used. So the 2 is the moderate, which is coded as 2. The 2 is not magnitude in terms of more by 1 unit from 1, and 3 is not 2 unit more than 1. It only says the gradient, that 1 3, somebody who has a disease 3 and somebody who has a disease 1, so that means the 3 is on the higher side. You cannot say that suppose 1 and 3, so 3 is the 3 times of 1, so that does not mean that the disease, the person who is having stage 3 or the severe disease, does not mean this disease quantity is 3 times that of the mild one. So this is just a gradient what is there, right? So quantitative variable can be categorized into continuous variable and discrete also. Continuous variable, it can assume an infinite number of real values within a given interval, like height, weight, blood sugar, etc. Infinite means, suppose you have got a value, height is 170 centimeter, and the next boy has a 175. There could be 172 also, 171 also. Somebody says 170 and 171, you could have 170 and 170.5. So there are always infinite number of values between two values. So that definitely, if you recollect, you must have read it in the school books when you read real numbers and all. So that is the meaning of continuous variable. That means that there is, we cannot cut that. To put it in other words, we cannot judge what is the next number and what is the previous number. But in case of discrete variable, a variable can assume only a finite number of real values within a given interval, right? Suppose you're recording something which is 0 to 10 or 0 to 50 or something like that. So 0, 1, 2, 3. And let me just put it there. These one usually confuses that if there is a fraction, it is continuous. If it is not a fraction, it is discrete. No, it is not like that. For example, I'll give you, suppose if you have if you look at your bank passbook, you have got the value of your balance is 20,000 50 paisa. So many times we think that it is a continuous variable. No, it is not. It is a discrete variable, 20,000 rupees 50 paisa. The next number is 20,051 paisa, and the previous one is 49 paisa. So you know that what's the next number and what's the previous number, because there's no half paisa in between. So when we can judge the next number or the previous number, that means the value is discrete. In continuous, we cannot judge that. So that's the difference between discrete and the continuous variables are further divided into interval scale measurement and the ratio scale measurement. Well, looks a very complicated word, but nothing in it. An interval scale is the one where there is an order, and difference between the two values is meaningful, and the presence of 0 is arbitrary. Very straightforward, and the very most popular example which you find in the text or the internet or all, the temperatures. 0-degree temperature means that the temperature is very cool. It has a significance that ice freezes, the water becomes ice at 0 degrees. But 0 does not mean it non-existence. So this is interval scale. What here, I mean, suppose there's a 40-degree temperatures, and one is at one place the temperature is 20 degrees. So we cannot say that the temperature of 40 degrees 2 times that of 20 degrees. We can say that the temperature of one city is 40 degrees and another city is 20 degrees. There's a difference of 20 degrees, because there is nothing like 0. 0 in other scale, which I'll come to it. The 0 means the non-existence. In interval scale, 0 has some meaning. It is arbitrary. So 0 °C has a meaning. So this is called a interval scale measurement. Next is a ratio scale measurement. Ratio scale measurement is a quantity where there's a true 0 existing. Suppose 0 weight, you can say 0 kg weight. 0 kg weight means it's a non-existence of something, non-existence of matter. Even gas, which is very light, has some weight. But when we say 0, 0 means the matter doesn't exist actually. but which is not there in case of. So for instance, it can be stated that person with 50 kg body weight is twice as that of person with a body weight of 25 kg, unlike interval scale. But it can also be said that person with a body weight of 50 kg is 25 kg more than that of person like interval scale. So this has the properties of interval scale, as well as uh, it facilitates the multiplication as well as division, which is not there in the interval scale. The number 0 means that the data has no value point. Weight, height, BP as 0 has no meaning actually. So these are the basic properties of that. In nominal, the categories are there only. In case of ordinal, you have categories and then rank also. That means you can say that in ordinal case, it could be a category, but there could be a gradient also. Interval scale, you have categories, you have rank, you have spacing, equal spacing. In ratio, you have all four properties. So what are descriptive statistics? Since it was important to learn the type of variables which needs to be described. So that's what I touched upon, those things. So measures of basic features of the data in the study. So yesterday we saw the descriptives in terms of visual presentation. Today we'll try to summarize the data actually. Together with a simple graphic analysis, they form the basic virtually every quantitative analysis of data. Descriptive measures mean measures of central tendency and measures of variability. And graphical. These are the three things which describes the whole data in fact. So what are the important characteristics of the data? Center, a representative or an average value that indicates where the middle of the data set is located. Right? Variation, a measure of amount that the values vary among themselves, usually from the central value. So that is what you have those standard deviation and variations. Distribution, the nature or the shape of the distribution of data, such as bell shape, or you might recall normal distribution and all. Then it also helps to identify somewhere outliers. So outliers, I mean, it's not a very simple thing to say that this is an outlier. There has to be a thorough reason to believe that how this value is outlier. Suppose let me just remind our young researchers when they are collecting their data for the thesis and all. Suppose they find some value very odd. So because they feel that this might interfere with their data, they try to remove it, considering it an outlier. No, that cannot be done. It has to be decided what is an outlier, and there has to be a clear concept to identify when, like it goes, suppose it goes beyond 3 standard deviation. So, and there has to be some principle behind it, which has to be discussed with the mentor, and then the outliers are decided. And the time, how the characteristics of data are changing over time. So measures of central tendency are divided into mathematical averages, which are mathematical averages are arithmetic mean, geometric mean, or harmonic mean. When we talk about mean without any special reference, we always refer to it as arithmetic mean. Geometric mean and harmonic mean are the special cases. They are used when a specific situation needs it actually. So by default, when we talk, we talk only about arithmetic mean. So positional or partitioned averages, mode, median, quartiles, deciles, and percentiles. These are the partitioned values. Let's look at it. This is the basic graph, which I think I talked yesterday also, box and whisker plot. It majorly summarizes the data. It says what is the central value. It speaks about the mean. It speaks about the median. Speaks about the lower quartile. Speaks about the upper quartile, maximum value, minimum value. It gives a bird eye scenario to the whole data you have. So mean, it is an average of the given data. So that means it is basically a representative of all the data set points. Yeah, I hope I'll agree what mean means. Don't think that mean is only simply, keep it in mind that it is the number you add and then divided by the frequency. Mean means it is somebody who is representing the whole data. To put it on a lighter note, suppose you have a family of husband, wife, kids, and the grandparents of the children. So, and one needs to attend to a marriage. This is just on a lighter note. I'm making this a light example. So, one person is required to attend a marriage. So the father says, कि भाई बच्चे घर पे हैं और ऐसे करो तुम चले जाओ. So somewhere he picked up a middle person कि elderly भी नहीं गए, बच्चे भी नहीं गए, so he picked up a someone कि आप चले जाओ. It is like that. So average is like a data. That means the data when is representing mean, so that means you assume that whole values are like that. But whether they are like that or not, that's a different thing, which is usually seen through a concept of variation, or maybe that can be taken up. So average, when you say you add the numbers and divide, is a computation. But imagine, so when you have done so, like for example, there's a class of students, and the teacher feels how the students are doing. Then he asks the mathematics teacher, "Bhai, आपका average score क्या है?" The teacher says that they are good, doing well. The average कितना 70% है. So I mean, the principal feels very satisfied कि 70% है, ठीक है. So that means what he's trying to imagine is that every person is around 70%. Whether that is there or not, they are further seen by the measures of dispersion and further analysis. I mean, that will be beyond somewhere in the next classes, right? So this is just a way of calculating the group data. You have frequency multiply. These are basic computations which you can find it anywhere in the thing. But I always believe that what you do, always pocket the concept behind it. That is the most sustainable part of any learning. So arithmetic mean, simple, add the numbers and divided by n, you get a mean. What does the geometric mean? You multiply all those numbers, and the numbers which you have multiplied, say suppose you have multiplied n numbers, so nth root is the geometric mean. Suppose you have got three numbers, you multiplied them and take the cube root. So this is usually used in the medical people can understand better when you're talking about when the values move in the multiples. Usually what I'm given to understand that when you're using the tighter values for studying the immunogenicity studies, there the geometric means are preferred. Harmonic mean, it is the reciprocal of the values of the arithmetic mean, right? So always remember, arithmetic mean is greater than geometric mean and geometric mean is greater than harmonic. So what are the merits and demerits? Merits of mean, easy to calculate based on all observations. This is very important. Why it is important? I mean, I'll come to median later, but I'll just speak a word about it here itself. Median. What is a median? Median is basically the central value of the whole data. So the demerit of that is it is only the one value. It is not concerned what the other values are. But when you calculate mean takes into account all values. Easy to understand because that is what I mean. I told you that I gave you some funny examples and all. So stable measure, not much affected by sampling fluctuation. If efficient sampling, sorry for this spelling mistakes, efficient sampling. So that means stable for measure means suppose you've got a sample of suppose you've got a population of 100 units and you are drawing 50, 30 or 40 units, whatever you are, and there could be number of samples out of this. If you know that suppose the population size is 100 and you are drawing the samples, population of 40, so 100 see 40, then so many number of samples can be drawn. So thousand and lakhs of samples can be drawn. So it says if one does a survey with some number and other person comes over here and he draws a sample, obviously he'll have different different units from that, but it is not likely to vary much. So this is a stable measure. Maybe the more details can be studied in different classes on different situations when it arises. So more reliable when extreme values demand some consideration. This is such a wonderful line. I suppose, for example, a doctor is treating the patients, and the point is could be a merit and could be a demerit also. Suppose most of the patient he feels are getting treated in 4 or 5 days. So the average he feels would fall somewhere between 4 and 6, something like that. When suddenly he sees after some time the patients are getting cured in somebody is getting cured in 10 days or 15 days. So that means for that doctor that is important. How the values are changing. He could go into more details for that analysis. That's a different thing. But when extreme values are in consideration, then your mean increases from 6 to say it might increase to 9 days. So that means you know that a person is likely to get cured in 9 days and not in 6 days. But suppose, and moving on to the next example, what are the demerits? Most affected. At one stage it was a merit, and another stage the same situation becomes a demerit. But that depends on the nature of data or the situation what the researcher is into. It is not only guided by the only mathematicians or the statistician. It is the decision. The decision maker is the researcher or a clinician or a biomedical scientist, that he feels that if that value is important, he should not use the median. So it is demerit is most affected. For example, duration of sickness in 10 patients. So most of the patient, 9 out of 10 patients were sick for 5 to 10 days. But one patient got cured in 73 days. So, but now here, if the doctor feels that these were the things which were different for with that patient, that is why the mean got higher side. So he could put it in a separate way, he could analyze in a separate way. But if he feels that the patient was same but still got cured in 73 days and had all the same characteristics and few more were there if at all, then this value would have been important as I mentioned in the previous statement. So if you feel that some value is somewhere out of place in that, then the mean may not be a good idea to calculate, because that will inflate the mean. So the same situation could be merit and same situation could be demerit. So that depends on the researcher. And let me frankly tell you, not by the statistician. That is guided by the researcher, biomedical researcher, and not a statistician. And the change of origin and scale affects mean. Suppose if you add all, say for example, there's a data. If suppose you add some value to it, say 5 is added to every individual, the mean also gets inflated by 5. So positional average. Now it's the positional average. Median is the positional average. Positional central tendency. Positional means here you are concerned with the value with the position. And the magnitude comes later. What is the central value? So that is the median. This value is not concerned what was the first value and what was the last value. So this is the central value. But these positional averages have a very meaningful notion. Other partition values are quartiles. Quartiles means we are dividing the data into 4 parts. Deciles means 10 parts. Percentile means 100 parts. So percentile is nowadays a very popular figure, because the whole marks when you appear for any competitive exams, you get percentiles. Percentiles means these are the positions what you are. What you have scored is less important. Your position is more important. These are used. One simple example. Suppose, I mean, very simple and the chalu example, I should say that. Suppose, I mean, somebody has collected a data on blood pressure, and he sees that most of the people in that group were hypertensive. He said, see, the average is something like 160. Systolic blood pressure is 160, and then you see that most of them, and the clinician says and presents to his department that in this area most of the people are hypertensive, and then some intervention was planned and all those things were done, and then again the data was collected, right? And the data was collected. So now if he finds that the third quartile, the value is say 140. So that means now there's with this one particular figure, the intervention people are complacent, they feel more comfortable that only 25% people are there who have got a blood pressure of more than 140. So they feel that 3/4 of the population is killed with that intervention. With this simple word, you get some. Then you calculate mean and standard deviations, all those you can do. But these gives a basic hint to what kind of. So let's not use this as these summary measures as a just as a to fulfill the statistical component or cosmetic component. Try to use it as, and accordingly we can write our contents while writing our results. So most of the time simple to calculate and understand. This is not at all affected by extreme values. It has no concern, rather I should say that it's a central value. Suppose the central value is looking at the previous value, say previous example, the patient got cured in 9 days. So that means the central value is 9. So you can say that less than 50% of the people were cured in 9 days, and more than 9. So that gives an idea. So there, the 73 days on which the patient was cured is just simply ignored, right? So possible to explore when data is incomplete, when one knows the number of items in the sorted data. Suppose you have, I mean, somewhere you have not written properly, but you know that there were 100 observations. That's simple. Suppose you're recording the data in your register, and I mean, you've mentioned somewhere you missed it. So at least you can judge what is the central value. Helps to know the relative position, of course, that I've already spoken. Demerits, lack of representativeness, because it doesn't take the whole family of the data into consideration. Lack of algebraic treatment, no calculations much are involved into it. When median is located between two central values, then it does not, most of the time when the median is part of the data, mean may not be. And most of the time mean is not, in fact. Median could be, most of the time is part of the data, particularly when the data is in the odd number. For example, 2, 3, 4, 5, 6, 7. So suppose there are 7 observations, fourth data is a mean. Suppose there are 6 observations, then what is the mean and what is the median? It is the third and fourth value when divided by 2 is the median. So there, in that situation, in case of even observations, the data may not be part of the median, may not be part of the data. So simple value is to calculate, suppose it is ungrouped data, you can arrange the data in the ascending order. And since this is an example, what you're looking at, it has got the even numbers. So 8 plus 8 divided by 2 is 8. So the middle value. But in case of group data, compilation of median is a lower limit. Suppose you have got a group data 0 to 5, 5 to 10, then you calculate the cumulative frequency. And there's a formula, cumulative frequency minus the total frequency divided by 2 and minus cumulative frequency of that particular class interval divided by frequency. So this is just a computation part, which I'll not get into it. You can easily find in any of the basic books, and try, didn't feel like bothering you with the calculations at this stage, rather than putting it in the words, what it means actually. That was my purpose. So H is a class interval. So this is what it tells about the median. So this is a small calculation part. And quartiles, as I mentioned, the quartile divides the data into 4 parts. Right? What is the second quartile? Second quartile is the median, basically. So first quartile means 1/4 of the data. You make a three slices on the data: 1/4, half, 3/4. So as the example what I gave you, suppose you have collected a data on blood pressure and you get a third quartile value is 140. So reasonably, the researcher or the program people can feel comfortable that 75% of the people have got a blood pressure less than 140, systolic blood pressure. So a reasonably comfortable zone. But 25% have, and I mean, what is that higher range? You don't know, but you know that 25% of the people have got blood pressure more than 140. And so this is the first and third quartile. And deciles, you divide the data into 10 parts. Percentile, you divide the data into 100 parts. When of course that you all know it, but let me, as a ritual, let me repeat that. Suppose that your child gets a value and appears for in competitive exams, gets 99th percentile. So that means 99th percentile means the person, only 1% of people are above him. So if you know that suppose 1 lakh people appeared and you are in the 99th percentile and so many seats are there, so the number of people in that category, if are less than the number of seats, so when you, whatever number you have scored, you are not concerned. You are very comfortable that you will get the seat. So that is why the percentiles are given. Percentiles are the relative positions, and actual numbers are the numbers what a student has scored. So in competitive exams, the percentiles are more relevant. Even if you have scored, suppose if you have scored 50% marks and you are in the 99th percentile, so that means the paper was so tough that even the students could not attend. I mean, your ward could get 99 percentile, so selection ho hi jayega. Number kuch bhi aaye, kya farak padta. So that is why these values are used in our day-to-day life. Mode is a very simple thing. Mode is that the number which has got the highest frequency. You go to market and you ask for a shirt of size 34, 36, for whatever the number, which is a popular size, so you get more variety of it. So that means that particular value has maximum frequency. So accordingly, you pick up that what the value is and use it as the need arises. In marketing, the demand is related to the mode. The size which is most popular has more variety, and which has got less. Uh, Suppose they're very thin people, so they'll have a less choice. So if they're obese people, they'll get the product on a higher side, on a higher price, and with a less variety because the demand is less. So frequency of the data of the consent variable helps to determine the marketing strategy. Just a formula for to you remember. This is usually many times asked in the small examinations or in MCQs or in basic questions. Mode is equal to 3 median minus 2. It is just an approximation, but I'll appreciate if you could remember it. It could be used in various exams if you're appearing for. So mode is a simple measure, not affected by extreme values, good representative measure, easy to locate and graph. Example I have already given. Important values may be ignored. Only, कहेंगे ना कि you're moving with the majority. So not capable of algebraic treatment. Statistical comparisons are not popular. When different class intervals show same frequency, difficult to interpret. So this is the computation of mode in the group data. F1 minus F0. So L is the lower limit of the model class, F1 the frequency of the model class, F0 frequency of the class preceding model class. These are the computations which I'll not get into. As per your comfort, you could do it. Because these are more important from the examination point of view rather than from the these kind of programs. But as a ritual, I had to put it into it actually. So this is just an example. You can do it on the. This is how the normal distribution data, what you must have had in your school days and the park book. This is how it looks like in normal distribution. Mean, median, mode are same. So thank you so much. This was all summary measures on the central tendency. Maybe the measures of dispersion, I understand somebody else is likely to take. So I'm stopping here. Thank you so much. You can get in touch with me if you wish to.
Thank you so much, sir, for a very amazing session. Now, I would ask that if there is any query regarding today's session, then all participants are free to write their query in the chat box or raise your hand so I can send you a unmute request. Please write your query in the chat box either or raise your hand so I can send you a unmute request. Thank you, Dr. Archana, Dr. Shruti for positive feedback. Thank you so much. And please, if there is any query regarding today's session, then please write in the chat box or raise your hand. We are just waiting for your queries. Thank you, Dr. Manish. Thank you. Thank you so much. I hope that all participants get benefited from today's session. Still not receiving any queries. I think that everything is clear. Sir,
must have got in other lectures also that these things.
right, sir. Right, sir. I think everything is
If audience are not, I have a question, sir. Many times this is asked by my students, and I am finding myself at a very tough spot to answer those. They often ask me, in thesis or in paper, all conclusions are based upon the inferential statistics. Why we choose to do differential descriptive statistics then?
नहीं नहीं, एक्चुअली इन केस ऑफ इन्फ्रेंशियल आप कैसे करेंगे? इन्फ्रेंशियल डिस्क्रिप्टिव से ही तो जाएंगे। अगर एक मीन आपने निकाला है, किसी दूसरे ग्रुप से कंपेयर कर रहे हैं, तो डिस्क्राइब करके ही तो कंपेयर कर पाएंगे ना। द फर्स्ट स्टेप इज डिस्क्रिप्टिव एंड देन यू कम टू, आई मीन यू कैन नॉट जंप टू इन्फ्रेंशियल विदाउट डिस्क्रिप्टिव।
So
मीन
this is
कंपेयर
a
करना है आपको दो ग्रुप्स को। सपोज एक ग्रुप में आपने एक मीन निकाला, सपोज कुछ निकला, and then mean blood sugar level is something like 120 and another group is 130, whether this is different or not. So description को ही तो हम interpret करेंगे ना, infer करेंगे.
okay. So this is
So
a
that's the big
stepwise
technique.
process. Okay, we cannot go to the analytical inferential
You cannot
statistics
go
without.
unless you have described it as based on the distribution of the study.
So
Thank you. I left a mail ID in the chat box. Request to participants, if there is any query regarding any session, then please revert on that mail ID and mention the subject as the name of the topic. So I can forward that query to the our associated guest speaker. And now I would like to invite our respected chairperson of the session, Dr. Hitesh sir, to share some views regarding today's session and kindly sum today's session. Sir, please. Sir.
yeah, I feel that Dr. Atul Juneja has made the things which look very difficult to the medical researchers very easy. The way he has explained the representativeness of mean, that it is a family member, that which family member would be representing in the gathering. And I think nobody will forget what mean is and what is its
Thank you so much, sir.
significance. And the way you have, I think the formulas which you have given, at one or the other times, these may be useful to the teachers whenever
Yes.
they have to teach to their students. I think
Absolutely.
you have given us a very nice feast for the descriptive statistics. Thank you very much, sir.
Thank you.
Thank you so much, sir, for your kind words. And now this is the end of today's session. Now I would like to thank all participants for their active participation regarding during today's session. I again heartily thanks to our respected chairperson, Dr. Hitesh Khurana sir, for their your presence and positive feedback regarding the session. I again thanks our resource person, Dr. Atul Juneja sir, for making session very amazing and clarify all things very precisely. And thank you, sir. Thank you for your valuable time. And thank you very much. This is the end of today's session. And our next session is on 13th, Descriptive Statics 3, the measure of variability, presented by Dr. Dharmendra Yadav, sir. And this is the end of today's session. Thank you so much.
Thanks.
Thank you.